Okay, this is number 35. We got several little parts to this problem. And the first one, it says find the ratio of the area inside the square but outside the circle to the area of the square in the picture below. So this is the A part. So basically the area here, we want this area here that's inside the square but outside the circle. So the way we could find that would be to take the area of the square and subtract from it the area of the circle. Well, the radius of the circle is r, the area of the square, well, the side of the square is 2r. So we have enough data there, so we can just kind of use our basic geometric formulas for area. So the area of the square is 2r, that's the side squared, which is 4r squared. The area of the circle is pi r squared. And the area that's inside the square but outside the circle would be just to subtract the circle from the square. So that's 4r squared minus pi r squared. And then we want the ratio of this to the area of the square, which is just the 4r squared. So here we have the area of the square minus the area of the circle over the area of the square. 4r squared minus pi r squared all over 4r squared. We can factor r squared out here. And then we can cancel those r squares. So we just end up with 4 minus pi over 4. And then this would have been fine to leave it in this form, but for some reason they just broke it up into two fractions, 4 over 4 minus pi over 4, which is the same thing as 1 minus pi over 4. Okay. The B part, they just want you to find the perimeter of this window here. Well, this is r, that's the radius. There would be another r over here. So that means that this rectangular part here, or this little segment here, would be 2r. This is r, and then this is a semicircle. So I just want to find the circumference of a semicircle added to these r, 2r, and r. And we have the perimeter. Okay, so remember the circumference of a circle is pi times diameter, or pi times 2r. But we want half of that, so half of the circumference of the circle is half of pi times 2r. Those cancel, so that's the area of the semicircle. I'm sorry, that's the circumference, pardon me. That's the circumference of the semicircle. We want half the circumference. So that's pi r. And then again, we had an r, 2r, and r. And that was the part of the rectangle. Again, I'll show you. We had r, 2r, and r, so that's this much, plus that semicircle circumference. So basically, r plus 2r plus r is 4r, plus pi r, which is the circumference of the semicircle, and that's our perimeter all the way around. So that wasn't too bad. Letter C, this is a little more complicated, and we do these a lot in some problems we call related rates. And they say a water tank has the shape of a cone, like an ice cream cone without the ice cream. That tank is 10 meters high, so the tank is 10 meters high. And has a radius of 3 meters at the top. Okay, if the water is 5 meters deep at the middle, what is the surface area at the top of the water? So it's filled up to this point here. So we want to find the surface area here, or actually the area of this circle. Well, again, we've got similar triangles if you think about this, because this is a right angle. That's the altitude. And then if we have a little cone, we can think of that altitude as a right angle, or this corner is a right angle. So we got two right angles, and we have a common angle again. So these two triangles are similar by angle, angle. So we know the ratio of the corresponding sides is the same. So this side, small to the altitude, 3 is to 10, as r is to 5. Okay, so short to 10 is the same thing as r is to 5. So those ratios are the same. Okay. So it's kind of, we could have also written it as 10 over 5 equals 3 over r. That would have been the same thing. It probably would have made a little more sense. I kind of wrote it like this, but we could have written it like this. Short side, well, let's say 10 is to 5. Because these are equivalent ratios, but it'll work out. 10 is to 5, as 3 is to r. And then if you cross multiply, this is just the same thing as 2 equals 3 over r. And then you would have 2r equals 3, so r equals 3 over 2. That might be probably a little bit more, straightforward. Okay, so it'd be large side to short side, large side to short side. Okay? So we know that r is 3 over 2. So that's my radius, and the area of the circle is pi r squared, so pi times 3 over 2 squared. And 3 squared is 9, 2 squared is 4, so that's basically your area. So this is probably a little bit more, like I said, direct way. Okay, a large side to small side, large radius to small radius. Okay, so that wasn't too bad on C. Okay, letter D. Two cars are moving, one moving west, one moving south. All right, and one car travels at 100 kilometers per hour, the other west at 50 kilometers per hour. How far are they after 2 hours? So if this car is going 50 kilometers per hour, and it's going west, in 2 hours it's gone 100. If this is going 100 kilometers per hour south, in 2 hours it's gone 200. So now we just have a simple Pythagorean theorem. A squared plus b squared equals c squared. In this case, 100 squared plus 200 squared equals d squared. So 100 squared is 10,000. 200 squared is 4, followed by 4 zeros, just double the number of zeros when you square it. And 10,000 plus 40,000 is 50,000. So, and then that's what d squared equals. So we get to take the square root of both sides. So d equals the square root of 50,000, which is the same thing as 10,000 times 5. And the square root of 10,000 is 100. So we just have 100 times the square root of 5 kilometers. So that's not too bad either. Okay, and the last one, a kite is 100 meters above the ground. If there's 200 meters of string out, what is the angle between the string and the horizontal? Assume that the string is a perfectly straight line. Okay, so this is what we have here. So I drew a sketch. There's my kite. There's the string. There's how high it is. This is a right angle. It's right above it. So I have a right triangle. So we can just set up, use our good old SOHCAHTOA from trig, and we know that if this is theta, this is the opposite. That's the hypotenuse. So the sine of theta equals the opposite over the hypotenuse, which is 1/2. And then we just take the inverse sine of both sides. So the inverse sine of the sine of theta is just theta. And the angle whose sine is 1/2 is what? Pi over 6, or 30 degrees. Okay? So I hope those are okay. And again, if you ever have any questions on these, just email me and I'll be happy to do a little bit more detail on these.